So hello and welcome back. So in this video we want to do example try number 6 on page 471. So this is basically the graph of the function that has been given also in the book, and the question is find an equation for the exponential function graphed in figure 6. So you already know that you are basically assuming that this is an exponential function, otherwise you would not be allowed to take this general form of f of x is equal to a times b raised to the power x. Because we are assuming that this is an exponential function, this is the graph of an exponential function, then we can use this general form of an exponential function to write an equation for this graph. Otherwise you could not just simply take this graph and then use this general form and then write an expression. It might, for example, you already know that you have a point here 2, 3 here, this point, and then you have another point here 0, square root of 2, and then basically if you did so, if you were not sure that this was actually the graph of an exponential function, you might use this general form, and then you would get some sort of relationship between x and f of x, and that relationship might work for example one of these points. For example, if you used this point and this point to find out what a and b was, so then you might find some relationship between x and f of x where these 2 points were a part of that relationship. Basically these 2 points were a part of that relationship, but then other points on this graph would not be a part of that relationship, and so then the model would simply not work. So I know that this is the general form of an exponential function, and I'm assuming that this is the graph of an exponential function. Therefore I can use this general form of the exponential function to rewrite or to write an equation for this graph. Otherwise I could not simply take this general form. I might have to take the general form of some other function, and then using that write the equation for this graph. So with that out of the way, assuming that this is the graph of an exponential function, then I can use this general form and write an equation for this graph. So basically I know that you always need 2 points. It's either the initial value of the function and another point on the graph of the function, or basically any 2 points, and then you would have to do a couple of things and then find what your a is and find what your b is, and then you will have written essentially the equation of the function. So now I know that the initial value of this function is the square root of 2, because at x is equal to 0 the output of this function is square root of 2, which is something around 1.4, which is some point between 1 and 2. So basically I know that a is equal to square root of 2. Now in order to write the equation, I need a and I need b as well. So what is my b? In order to find b, I have another point on the graph of this function, which is 2, 3. I can use this point and write this equation using this point. So this becomes f of x here is 3 3 is equal to a, which is square root of 2. b, I do not know, so times b, raised to the power x, and x here is 2, so b squared. So then that basically means that b squared is equal to 3 over square root of 2. 3 over square root of 2. So that basically b is, if I take the square root of this side of the equation, the square root of 3 over the 4th root of 2, I guess. So basically, if I take the square root of b squared is equal to the square root of 3 over square root of 2, in order to get rid of this second power of b, I want to know what b is, but here I have the second power of b. So the square root of b squared is equal to b, and then the square root of this whole thing is, you could leave it this way, or you could rewrite it as the square root of 3 over the square root of 2. This is the second root of 2, and then the second root of 2, so it becomes the 4th root of 2. So then you can rewrite this as the second root of 3, or square root of 3, and the 4th root of 2. So I guess, if I'm not wrong, I can write this as a is the square root of 2, and your a is equal to square root of 2. So your f of x, which is a times b raised to the power x, is equal to a, which is square root of 2, and here you have times the square root of 3 over the 4th root of 2 whole raised to the power x. And now we can, let's see what well, basically based on this is basically the equation of this function. Now we can test it to see whether that's right or not. So based on what I see in the book, if I can basically trust the graph, because sometimes the graphs in the book are not that accurate. It just, sometimes it gives you some wrong input outputs based on the actual graph of the function. I'm saying that. So here I have the point 3, 4 on the graph of the function as well. So here I have this point becomes 3, 4. Let me see if that point is on the graph of this function. This point is 3, 4. So if my input is 3, let's see what happens here. So f of 3 here is equal to square root of 2 times square root of 3 over the 4th root of 2 raised to the power 3. Let me calculate this. I don't know what's going to happen here. Let me calculate this. This is the square root of 3 whole cube, which would be let me use the calculator. So I have entered this into my calculator, and as well, based on according to my calculator, it says that this expression is equal to something approximately equal to 4.4. So it makes sense, because kind of makes sense because here f of 3 is equal to is approximately equal to 4.4, and here I had on the graph of the function I had 3 comma 4 as a point on the graph of the function. So that's basically how you would write an equation for based on the graph of the function. And now that we have some time, so basically in the next part of the book, so here I have this how-to here. It says given 2 points on the curve of an exponential function, use a graphing calculator to find the equation. So this is basically, you need to know how your own calculator works. Different calculators have different ways of entering the data, and then different ways of showing the data. And your calculator, whatever that might be, of course I'm assuming that it's a scientific calculator. It's not that I mean, it doesn't necessarily have to have L1 and L2 and I don't know, well, maybe exponential regression is a part of all of such calculators, but basically it's always a different way. Basically it's always different to work with different calculators. So for this you need to know your own calculator. If you don't know, you need to read the user's manual, know how it works, and then you have the graph of the function, for example, something like this, and then you have 2 points on the graph of this function, 1 point here and let's say 1 point here, and then you enter those two outputs into your calculator, and your calculator will calculate A and B for you, as we did in this example, and then it will give you an equation for that graph, assuming that the graph was the graph of an exponential function to begin with. So basically there is some other parts here that says using a graphing calculator to find exponential functions, stat edit this and that, and I mean, based on my own calculator I could tell you what to do here probably, but I don't know what sort of calculator you have. You need to know how your own calculator works. And so that's all I can say to you about this. Again, using a graphing calculator to find this and that function. And then here we are in the beginning of the section in the book that is all about compound interest formula, and basically it's some sort of application of exponential functions. But I guess before we move any further, I guess we stop here in the book. And I have, as I mentioned before, I have found some very good examples of exponential functions on Khan Academy. So I will, of course, I'm borrowing them from the Khan Academy. They're not mine. They have done a great job of having all of these great examples. And they have done all of these examples they have integrated all of these examples in their software. It corrects everything for you. It even gives you hints. It tells you how to do different things. So whenever you have any problems with I guess any part in mathematics, you can simply go there and use their platform. It's a great platform. I'm a big fan. So And I have taken all of these different examples from the Khan Academy. This way you can understand word problems, and you will also understand how to interpret word problems and then turn them into algebraic expressions, and then use the concepts that you have learned in exponential functions to solve those problems. Those are great problems. We will talk about them after this video, and then we will come back here and talk about these compound interest formula and formulae and all of these things that we find over here. So thank you, and I'll see you in the next video. Bye for now.